Hello everyone. Today's my topic is a graph theory in network analysis and synthesis subject. So start from the basic of the graph theory. This theory basically used to solve different electrical circuits which is made of active or passive elements. Active elements are those elements which is used to deliver energy to the system, and the passive elements are those elements which are consume the electrical energy. So an electrical circuit is made of two elements. After solving these circuit, we are using different type of technique. We are using a different theorems and first and Kirchhoff's law. So the solution of the electrical circuit are very complicated. A new method, here we are using a new method of a graph theory, which is a graphical representation of the electrical circuit, which is reduce the complex system or reduce some electrical differential equation by using the graph system. So this theory is also called as the network topologies. Here we are using a matrix method to solve electrical circuit without using any differential equations. So the length of the solution is also reducing, and time consumption to solve or calculating electrical power, current and voltage is also reduces. Here I am taking an electrical circuit which is made of some voltage source, current source and passive elements. Passive elements are categorized into the three parts: R, L and C, inductor, capacitor and resistor. This circuit is purely resistive circuit which I am taking to convert this electrical circuit into a graph network. So here we are seeing that there are some points first, second, third and fourth. These are selected as a node. Node means a point at which more than two branches are meet. और इसको हम ऐसे भी कह सकते हैं कि जहां पर हम किसी एनर्जी को ट्रांसफर करते समय हमारे पास ऑप्शन हो कि उनको किन किन जगह पे भेजा जा सके, उस पॉइंट को भी हम लोग नोड कहते हैं. नोड बेसिकली अगर आपको क्लासिफाई करना हो तो एक ऐसा पॉइंट जहां पर मिनिमम तीन ब्रांचें या दो से ज्यादा ब्रांचें आके मीट कर रही हो. So in this graph, I will taking first as a node. Second point, here three branches are made. Second point is also called as a node. Third, at the third point, four branches are made. So third taking as a node. Last one is a fourth one. Fourth one taking as a reference node as compared to the first, second and third node. These nodes are connecting with the branch basically a path which is connected between the two nodes. Here R1 is considered as a path which is connected between the first and second node. Same type R2 is taking also as a branch, R3 is taking also as a branch, R4, R5 and current and voltage source which is connected in a wire taking as a branch. So after taking this example and converting into a graph theory, we are taking some assumptions. These assumptions are voltage source taking as a short circuit in the graph theory. Second one is a current source. Current source taking as an open circuit type behavior in a graph theory. And last one is a passive element. These passive elements consider R, L and C type of element, and these are also come under the short circuit conditions. So this graph is converted into using a graph theory. This is a graphical representation of an electrical circuit by using these assumptions. So first one is first place 3 and 4 node, first, second, third and fourth. After replacing these elements as a short circuit is a branch B, D, C and F, and the voltage source branch considered as a short circuit which is represented here as a E, and the current branch taking as a open circuit. So I will draw this branch like this. This is the open circuit branch, and the last one is the R5 branch, which is also a passive component branch, considered as a short circuit, which is represented here as a A notation. So this is the complete diagram of the electrical system using the graph theory. So now come on the next topic in the types of a graph. This graph theory is basically divided into these type of graphs. These type of graphs consider this type of electrical system or electrical circuit by using with directions, with non-directions, and first and second one is a connected graph, second one is a non-connected graph, third one is a directed graph, and fourth one is a undirected graph. In the connected graph, I will consider this electrical system circuit convert into a graph, so all the nodes are connected in a same graph. Second one is a unconnected graph. In this type of graph, we are taking all the nodes in a circuit, but only 3 or 4 nodes are taken in a circuit, and other nodes are considered is another type of circuit. So this type of graph separates an electrical system into a two parts. So this is called the unconnected graph. Third one is a directed graph. Directed graph, in this type of graph, we are taking a direction of a current, which is taken as an arrow, or transfer of energy of voltage and current source into a circuit. Fourth one is a undirected graph. In this graph, we are not showing any type of arrow or transfer of energy into a electrical circuit. Here I will taking a example of electrical circuit and convert into a graph. So first one is a connected graph. Here I have seen that all the nodes are connected with each other, and branches are also connected with all the nodes. Here the current branch is open because of the behavior of the current type. Second one is a unconnected graph. Here also we are taking a 4 node, but the graph is divided into a 2 part. These 3 nodes, second, third, and fourth, making a separate graph, and the node 1 is also making a new graph which is not connected with the other type of nodes. So this type of graph is called unconnected graph. The third type of the graph is called the directed graph. In this type of graph, we are taking the direction of the energy which is producing by the voltage source or current source in a circuit. So I will show the arrow. This arrow shows the energy transfer through the voltage source to the electrical elements that are present into the system. Here these elements are behave like a short circuit, so this arrow shows the electrical energy direction in an upward direction. Second and third shows the direction from the node 1 or energy transfer between the node 1 and second. So this direction shows the energy is transferred from the node 1, and second is a point where the energy transfer through the node 1 is reached. This type of graphs comes under the undirected graph. Fourth one type is a undirected graph. Here we are not using any type of arrow or energy transfer into the system, so this type of graph comes under the category of the undirected graph. बाकी 4 टाइपों के अलावा ये 2 टाइप ही ज्यादातर ग्राफ्स कंसीडर किए जाते हैं ग्राफ थ्योरी के अंदर, First one is a planar type of graph, second one is a non-planar type of graph. In a planar type of graph, all the nodes and branches are considered into a same plane. Here we are not using any type of crossing into the system, into an electrical circuit. So this type of circuit or graph comes under the planar graph. Second one is a non-planar type graph. Here I have seen that a branch which is crossing another branch by using a tilt type of circuit. So this is comes under the non-planar type of graphs. So thank you.